Okay, of chemistry. Okay, so if I'm talking about that, what is chemical equations and reactions? If I talk about this, what is chemical equations? So let's start. Chemical equation. Chemical equation and reactions. What is chemical equations and reactions? Let's talk about each and everything. Chemical equation means writing a chemical change in terms of symbols and formula. Okay. Writing a chemical change in terms of symbols and formula. If you write any chemical change, for example, I know that you will be very much familiar that what is chemical change, what is uh, okay, what is a physical change. For example, if you are burning a coal, okay, so it will gives you C. Coal is carbon, C plus O2 gives you CO2. This is chemical change. Okay, burning a hydrogen gas in here to give water, this is a chemical change. So if you write it, hydrogen gas burns in air to give water, okay. If you write this change, this chemical change in terms of symbols and formula, then we will consider it as a chemical equations. Okay, so writing a chemical change in terms of symbols and formula is called chemical equations. Okay, you understood? Writing a chemical change in terms of symbols and formula is called chemical equation. For example, H2 plus O2 gives you H2O. Okay, so this is what is this happening here? You have written this hydrogen has a symbol that is H2O2, and then water has a formula that is H2O. So this is, we considered it as chemical equation. This is chemical equation. Okay, this is chemical equation. Now, if I talk about this one, here this you see that this is 2 hydrogen atom, there is 2 hydrogen atom, this is 2 oxygen atom, but there is only 1 oxygen atom. So I cannot write it like this H2O2. Why? Because you know that in a chemical compounds, elements are combined in a fixed ratio by mass. Okay, we cannot combine, any element cannot combine with any number of atoms. Okay, yeah, the oxygen atom can combine maximum with 2 hydrogen atoms. So it can form H2O. It cannot form H3O. Okay, or H5O or HO only. It cannot form. It will always react when oxygen react with hydrogen, it will form H2O. This is a formula for the water. Okay, so here there is something missing. What is this missing? That is the law of conservation of mass is not the total number of atoms of the reactant side. This is called the reactant side, and this is called the product side. Okay, product side. So here the total number of atoms of each type means if there is 2 hydrogen atom, then there must be 2 of hydrogen atoms. If there is 2 oxygen atom, then there must be 2 oxygen atom. Okay, so the total number of atoms of each type should be equals on both the reactant and the product, both the sides. So if there is 2 hydrogen atom, there is only 2 hydrogen, there is 2 hydrogen atom, but there is only 1 oxygen atom. 2 oxygen atom, but there is only 1 oxygen atom. So this is lacking. So this type of equation is not balanced. This is called, it is not balanced. So this type of chemical equation is called skeleton chemical equation. You understood? Everybody understood in the class?
Yes, sir.
Yes, sir.
Done. So this is H2O2 gives you H2. Now talking about this one, H2 plus O2 gives you H2. If you balance this one, how to balance this one, we'll talk it later. This is H2, you write here and you balance it. You'll get 4 hydrogen atoms, 2 oxygen atoms. And when you multiply this one, you will get 2 hydrogen atoms, 4 hydrogen atoms. And this 2 is also going to multiply with this oxygen atoms also. Because if you are written H2O and 2 is here, so this 2 is multiplying here and 2 is also multiplying here. So this will gives you 2 oxygen atoms. Now you understood, everybody?
Yes,
it is balanced. Sir. It is balanced. Is there any doubt? No.
No, sir.
So this is called balanced chemical equation. This is called balanced chemical equation. Balanced chemical equation. Okay. Chemical equation. So what is a chemical equation? Writing a chemical change in terms of symbols and formula is called chemical equations. Okay. Got it? Everybody understood? Should I move forward?
Yes,
Yes,
sir.
sir.
Okay. Now let me explain you that sometimes the students are not familiar that how to write the chemical formula of the compound. That is very important. That how to write the chemical formula of the compound. Okay. They even don't know how to write the chemical formula of the compound. And if you are not able to write the chemical formula of the compound, then you might not be able to write the chemical equations. Okay. So if you are having the, for example, if I ask you to write the formula of sodium aluminate, or if I ask you to write the formula of sodium phosphate, sodium phosphate, calcium sulfate, zinc carbonate, aluminium oxide, ammonium chloride, lead nitrate, lead iodide, So can anybody in the class can tell me the formula of calcium for sodium phosphate? Sodium phosphate. It may be wrong or right. It's not necessary. You can tell me anything. Can you tell me the formula of sodium phosphate? Is there, do you know any of the formula of any one of the compound that I have written here? Formula of any one of the compound that I have written here? Aluminium oxide, zinc carbonate, calcium sulfate, lead nitrate, lead iodide. Any one of you? Hiba, Ajwad, Adil.
Lead nitrate PbNO3 twice.
PbNO3
Twice.
twice. Okay. Then other? Is there anyone? What is the formula of aluminium oxide? That is simple. Formula for aluminium oxide.
ALO, sir.
ALO. No. Okay. So wait a minute. Shweta is not here today. Shweta. Okay, let me help you that how can you write the formula of the compounds. Okay, dear students. For example, this is very simple. How can you write? You have to just memorize some valencies. And we'll provide you the valency chart. We'll send you the valency chart. You need to note it down in your copy. Okay. So let me help you that with the valency chart. That where is valency chart? Okay, look at this that I'm showing you here. Okay, this is the valency chart that you need to memorize. Okay, this is the valency chart. That is potassium is going to have +1 valency. Sodium is going to have +1 valency. Okay, copper is going to have +1. Silver is going to have, mercury is going to have +1. Silver is going to have +1. +1, if there is only plus sign, no 1 or 2 written, it means +1. Like chloride ion is going to have -1 valency. Bromide ion is going to have -1. Okay, so we will send you this chart that calcium has +2. Okay, so you have to note it down in your copy. Okay, let me say one thing to you that if you have memorized this chart, 50% of the chemistry is finished for you. You have done 50%. The rest for the whole year, you have to learn the 50%. This chart is so important that this will help you how to write the correct formula of the compound. If you even
So
don't
this
know how to
chart will
write,
be sent by WhatsApp.
yeah, this will be sent to you. Okay,
Okay,
this will be sent to your respective group. Okay, that you receive the message.
okay.
So this is important. For example, this is zinc. Like if I'm talking about zinc carbonate, there's zinc CuC, zinc 2 positive, and carbonate is CO3. CO3 and 2 is written, what the above this one is written as valency. the above number. Okay, this is 2 plus and this is 2 minus. So if I talk to you that what is the valency for this one? Okay, so you can write it like zinc carbonate can be written as zinc is valency 2. Here 2 is written, so you can write it 2 here. And carbonate is CO3 and minus 2 is written, so don't write minus 2 here. Okay, 2 is here. Okay, and this charge is written. When they have the same charges, they cancel out each other, and you can write the formula ZnCO3. For example, if you need to take aluminium oxide, aluminium is going to have +3 valency, and oxide ion is going to have -2 valency. So in this case, they will cross multiply with each other, and you have to write it Al2O3. Got it?
Yes, sir.
Got it?
Yes, sir.
This is Al2O3. If I'm talking about that sodium oxide, sodium is going to have +1 valency, oxygen is going to have 2 valency. Don't confuse with the minus and plus. That is not only you have to write the number. So then you have to multiply this one, cross multiply, you will get Na2O3. Na2O3. Sorry, Na2O. Na2O. Okay. So I'm just going to write some numbers here. For example, ammonium. This is ammonium, NH4 and +1. Okay, hydroxide, that is OH -1. Calcium, that is Ca2+. Okay, and this is oxide, this is O -2. Sulfate, that is SO4 -2. Okay, and that is sodium, Na1+. Okay, I'm just writing the important only. Potassium is Na, K+. Nitrate is NO3 -1. Okay, and aluminium, sodium, carbonate, sulfate, carbonate is CO3 -2. Okay, this I'm writing this for you. If I ask you to write the formula of calcium hydroxide, what should be the formula of calcium hydroxide? Calcium hydroxide,
CaOH2.
CaOH2. Yes, you have to write CaOH whole twice. This is calcium is 2 valency and OH is with -1. You can see this is only one minus sign written here. So you can multiply this one by 2 and you will get CaOH, because this 2 is going to multiply with this whole O and H both, because O and H is considered to be as one single entity here. So we have to write here this like this in bracket, because this 2 will now multiply with this one and this 2 will multiply with this 4. Okay, you understood calcium hydroxide formula?
Yes, sir.
What should be the
Yes, sir.
formula? What should be the formula for the ammonium sulfate? Ammonium sulfate. Formula for ammonium sulfate.
H4 SO4.
Ammonium sulfate,
So is it
H4
NH?
SO4.
NH4,
SO4.
and sulfate is SO4. Sulfate is SO4. This is SO4. Okay, you can write it SO4. There are for valency for ammonium is, tell me,
1,
NSO4.
2.
Then you cross multiply these two. What you will get? NH4. Now bracket,
NH4.
because this whole twice, then
Bracket
SO4.
2. So
Got it?
yes, sir.
What should be the formula for potassium oxide? Potassium oxide,
K2O.
K2O. Very good. What should be the formula for zinc carbonate? Zinc, I'm writing zinc carbonate. Zinc is Zn2+. Formula for zinc carbonate.
CnCO3.
ZnCO3. Very good. Because both are going to have that 2 valency, so this will cancel out each other and you can mix it. Okay. Now you understood?
Yes, sir.
Yes, sir.
Understood everybody?
Yes, sir.
Okay. So
Yes,
this is how you need to write. For example, if I ask you to write the formula of sodium zincate. Sodium is Na1 positive and zincate. Zincate is ZnO2. So what is the formula for sodium zincate? And this is the has a valency of -2. Like we have carbonate ion CO3, zincate is ZnO2.
Na bracket 2 Zn
No, if it is any single quantity, then don't write bracket. If it is more than one element is present, like in ammonium, we have nitrogen and hydrogen. So that's why we use
ZnO2.
yes, Na2 ZnO. This is 2. Sorry, this is 1.
Na2
Yes, very good. This will cross multiply, it will get you Na2 ZnO2. So this all valency you can find here. Like you can find zincate. This is zincate ZnO2 -2. Okay, and like we have sodium. There is sodium. Sodium will be in 1. So this is all. Here is sodium. Okay, so this you need to memorize this one. Okay, you need to practice this one, and then it will be okay for you. You will be able to learn each and every formula of the compound. Okay.
Okay, sir.
Okay. Everybody understood in the class? Everybody
Yes,
in the
sir.
class?
Yes,
Is there
sir.
any doubt? No.
No, sir.
Should I
No,
move
sir.
forward? Okay. Now the next one is how to balance the chemical equations. And what is this? Why there is a need? First of all, how to balance the chemical equation. The second one is why there is a need to balance the chemical equations. Okay. So first of all, the question comes that why we are balancing the equation. Why there is a need to balance the chemical equation? Because as you know very well
Law,
that tell me law.
law of conservation of mass.
Yes, due to law of conservation of mass, the total mass of the reactant must be equal to the total mass of the product. So if I'm having the mass of one hydrogen atom is 1, so that there are 2 hydrogen atoms, this is 2. Mass of one oxygen atom is 16. Oxygen is 16, so O2 will be 32. H is 1, so H2 will be 2. So here it is 32. Now one hydrogen atom, there are 2 hydrogen atoms, the total mass of 2 hydrogen atoms will be 2. And one oxygen atom, that will be 16, that is total is 18, and here total is 34. So the total mass of the reactant is not equal to total mass of the product. So, and according to law of conservation of mass, then that according to this one, we say that the total mass of the reactant must be equal to the total mass of the product. Okay, got it? And
Yes,
according to
sir.
Yes,
Dalton,
sir.
according to Dalton dynamic theory postulate, according to Dalton dynamic theory, the total number of atoms of each type. For example, if I'm having N2 plus H2 will gives you ammonia, NH3. Okay. So if I'm talking about this N2, H2, and this will give you NH3. So you need to keep in mind that there are 4 atoms total and there are 4 atoms here. But it is still not balanced. Because according to Dalton dynamic theory, atoms can neither be created nor destroyed. And here you will see that here the 1 atom of nitrogen is destroyed. There is 2 nitrogen atom, there is only 1 nitrogen atom. And here there are 2 hydrogen atom and there is 3 hydrogen atoms, so it is created. So according to Dalton dynamic theory postulate, atoms can neither be created nor destroyed during a chemical reaction. And keep in mind that we are talking about the chemical reaction, not about the nuclear reactions. The laws of we can say that the law of conservation of mass or Dalton postulate, they are not applicable for the nuclear reaction. They are applicable for the chemical reactions. In which the atoms are not broken, their bond between the atoms is broken. And in nuclear reaction, the actual atom is split and broken into its subatomic particle like electron, proton, and neutron. So here we are not breaking the atoms. We are just breaking the bond between 2 atoms. For example, there are the 2 atoms are being combined with a bond. So we are just breaking this bond. So in chemical reaction, the bond between the 2 atoms are being broken and the new bonds are formed. But in nuclear reaction, the actual atom is broken. Actual atom is broken. So if I'm talking about this one, so according to Dalton dynamic theory postulate, the total number of atoms on the reactant side must be equal to total number of atoms on the product side. That's why a reaction must be balanced. Okay. Got it?
Yes, sir.
Got it? So
sir.
please note it down. Note it down. Why there is a need to write a balanced chemical equation, and everyone is requested to please don't take the screenshot, and you have to write the whole equation, everything in your copy, okay, for obtaining very good marks. Done. Note it fast. A chemical reaction must be balanced because according to law of conservation of mass can neither be created nor destroyed during a chemical change. And the total mass of the reactant and the product must be equal. And the second point is, according to Dalton atomic theory postulate, atoms can neither be created nor destroyed during a chemical reaction. Mark my point that we are talking about the chemical reactions. Okay. Hence, the total number of atoms of each type must be equal on both reactant and product side. Got it? When you're done this one, then
Yes,
we'll learn
sir.
how to write balanced chemical equation. Okay.
Yes, sir.
Faizan, noted.
Yes, sir.
Hiba, you also? Ajwad?
Yes, sir.
Okay. So let's move further. Let's talk about it further. Okay. The next one is how to balance a chemical equation. How to balance a chemical equation. Okay. So that there you need to follow the two rules. The two very simple rules that you need to follow. The first thing is that you will repeat only that element that is least repeating. Means that you will balance that element first that is least repeating. That is not multiple time repeating. Which element you are going to balance first? Tell me.
Least
That is
repeat.
least repeating. For example, if I'm having this FeSO4, when heated, it gives you Fe2O3 plus sulfur dioxide plus sulfur trioxide. So which element will you balance first in this one? Element. I'm talking about element. Either iron, sulfur, oxygen. Which one will you balance first?
Iron.
Iron, because iron is least repeating. It is only one time repeating. Don't get it with its two. No, it is only one time. Sulfur is repeating 2 times and oxygen is repeating 3 times. So least repeating element is iron. So we'll balance iron first. Okay. Okay. Understood?
Yes, sir.
Yes, sir.
And we will balance that element first. We will balance that element at last, which exists in its elementary or molecular form. Okay. For example, if I'm talking about that, that I'm having PbNO3 whole twice, and if I heat it, it will gives you PbO plus NO2 plus O2. So here oxygen is in purest form, that is NO2. So we will balance it. So it is maximum time repeating. First rule, it is also violating. And second rule is that if there is any element which exists in its molecular form or in its elementary form, then we will balance that element at the last. Okay, you understood? That we will balance this. We are going to balance this oxygen at the last. Why? Because it is existing in its elementary form. Like elementary form means like if an element is written alone, not bounded with any other things, like Na, like Cl2, like Br2, like H2, like C, like S. If it is written single, not bounded with other element, okay, then we will balance that element
Okay,
at
sir.
last. We will balance
Yes,
that
sir.
element at last. So everyone understood? Understood?
Yes, sir.
Yes, sir.
So balance. So note this point, these 2 points. How to balance a chemical equation? Note these 2 points. Noted these 2 points?
Yes, sir.
Yes, sir.
Okay, now balance this one. H3PO3, when heated, it will gives you H3PO4 plus PH3. Which element will you balance first? Decide which element will you balance first. Phosphorus, hydrogen, or oxygen? Which will you balance first?
Phosphorus.
Oxygen.
Oxygen. Yes,
Or
oxygen
is
is
it
single
hydrogen?
time. No, hydrogen is repeating 2 times here. And phosphorus is also repeating 2 times. So oxygen is only 1 time repeating. So we'll balance oxygen first. Okay. Here on the reactant side, how many oxygen atoms are there? 4. 4 oxygen atoms. And here we have 3 oxygen atoms. Okay. By what number should you multiply here and here so that they will become equal?
4 and
The
3.
2 numbers can be different. Huh?
4 and 3.
4 and 3. You have to multiply here 4 and you have to multiply here 3. If you multiply this 4 by 3, you will get 12. And when you multiply this 3 by 4, you will get 12. Okay. Got it? Got
Yes,
it?
sir.
Yes, sir.
So this is 4. So write here 4 and you cannot change the digit here. Only you can change this trigonometric option, means you can write here only. So this you have to write here 4 and you have to write here 3. Now after this one, you need to check whether the equation is balanced or not. Okay, don't start solving. Okay, so check now hydrogen, oxygen is balanced. Now check whether the phosphorus is balanced or not. We have balanced the oxygen. Now check how many of phosphorus atoms are there now? 4. So this 4 is going to multiply with this phosphorus also. And how many are there? 3, 3 and 1. 3 plus 1, you will get 4. 4 phosphorus on the both. And here how many hydrogen atoms are there? 4 3s are 12. And here how many are there? 9 and 3. This 3 gives you 12. So this reaction is balanced. Okay.
Yes, sir.
Okay, sir.
Balanced. Now try to
Yes.
balance. Noted this one. Try to balance this one. Fe2O3. Sorry, FeSO4. FeSO4. When heated, it gives you Fe2O3 plus sulfur dioxide plus sulfur trioxide. Balance this. Done?
Yes, sir.
How it is balanced? Tell me.
2 FeSO4.
Hmm. Yes, 2FeSO4, then the whole equation will be same. Okay. Now you check
Yes.
that this repeating is iron. So you write here, there are 2 iron. So you write here 2. And then you multiply this one, you will get 2 sulfur. Then this 2 sulfur already. Then you multiply this one, 8 oxygen. That is 3, 2, 5. And then 3, 8. Okay. Got
Yes,
it?
sir.
Everybody in the
Yes,
class
sir.
understood?
Yes, sir.
Okay. Now try to balance this one. PbNO3 whole twice gives you PbO plus NO2 plus O2. PbNO3 whole twice. Let me explain you one more time that how many nitrogen atoms are there? Here, how many nitrogen atoms are there? 2. Because this
2.
NO3 is in whole bracket with this one. So this is going to multiply with this one and this one also. Okay. Now start solving. Oxygen atoms are 6 on here. 3 to the 6. And how many lead atoms are there? 1. Because this 2 is not going to multiply here. Okay. This will only multiply with this NO3. Try to balance. Are you solving? Are you solving?
Yes, sir.
Try to solve it, then I will help you. Everybody in the class, try to solve. Have you done?
Yes, sir.
So what you get?
2 PbNHO3 twice gives
Hmm.
2 PbO plus 4 NO2 plus O2.
Okay. Okay. So how will you write it this one? Let me explain you that how you balance this one. Okay. So here you see that you are not going to balance the oxygen first. What are the two reasons that why you cannot balance the oxygen first? Because it is. Tell me why we are not balancing the oxygen first.
Sir, because it's not combined with any element.
Yes. First of all, it is not combined with any element. It is in molecular form. So we're going to balance it at the last, and moreover, it is multiple time repeated. Okay. So which element is least repeated? Both nitrogen and lead that are least repeated. They only one time. So you can either balance the lead, you can either balance the nitrogen. It's your choice. So lead is already balanced because lead is 1 and this is lead 1. It is already balanced. Now coming to the point here, there is 2 nitrogen here. There is only 1 nitrogen. So should I write it N2O2? Will it be balanced?
No, sir.
Tell me. No, it will be considered as incorrect. So you have to write two here. Okay. Got it? Now lead is balanced, nitrogen is balanced. Now the last is oxygen. Okay. So for balancing the oxygen, that how many oxygen atoms are there?
6.
6. And how many are there in total? 1 plus 2 twos are 4 plus 2 is 7. Okay. 7. So actually the problem is with the oxygen only. There are 6 oxygen atoms, there are 7 oxygen atoms. So if suppose this oxygen atoms is only O, only one oxygen atom is such like that, because oxygen is creating problem. If I just change the numerical value here or something right here, then lead will become unbalanced. Then I have to write here something also. So it will create a problem because oxygen is only creating a problem here. So what you need to do is you need to multiply the oxygen, this O2, because if you already have 5, this one 2, sorry 1 and 4, 5. The total number of oxygen with here is 5. If it become 1, 5 plus 1, it will become 6. So how can 2 can become 1? You cannot change it O2 because O2 is always oxygen atom exists in the O2 form. You cannot write O because you independent existence of O is not there. O always exists in the form of O2. So we have to write here 2. So how that 2 can become 1? By what number should you multiply this 2 so that it becomes 1? Tell me. By what number? It can be in fraction also. By what number should you multiply 2 so that it becomes 1?
1 by 2.
1 by 2. So you have to write here 1 by 2. This 2 will get cancelled out. You will get 1 here. So you have to multiply this half. If you multiply this half, this with half, so it is balanced. Now this is 1 oxygen atom, 1 oxygen, and 5. Now it is balanced, but it gives an awkward feeling that how can we write half molecule in an equation? We have to we cannot use this in that like this denominator form. Okay, so what we need to do in order to remove this denominator, whatever is being written in the denominator, we have to multiply the whole equation with that one. If 2 is written in the denominator, multiply the whole equation by 2. Why we are multiplying? Because if I multiply this one with 2, you will get 2 Pb NO3 whole twice. Got it? 2
Yes, sir.
Pb NO3 whole twice. When this 2 is being multiplied here, it will gives you 2 PbO. When this 2 is going to multiply here, this will gives you 2 to the 4 NO2.
4 NO2.
But when this 2 is going to multiply with this one here, so this half when going to multiply with 2, you will this 2 and 2 will get cancelled out and you can write here O2 only. Okay, so this is the benefit of multiplying the number that is in the denominator. So when this the turn of this multiplying comes, you multiply it get cancelled out and it gives you only O. Okay, now it is balanced.
Yes, sir.
Everyone understood?
Yes, sir.
Okay. Let's you balance the more equations, some more equations. Let you try to balance the C2H6. When bonds in oxygen, it will gives you carbon dioxide plus water. Try to balance this one.
Yeah. ऐसा कुछ करो क्या फिर तुम्हें बाहर ठहरो क्या तुम ऐसा
Done.
वेट करो अब चुप बैठो
Done. Done. All of you. Okay, let me help you. How can you write this one? This is C2H6 again. If you have done this one, that is better for you. Plus water. You know that oxygen is in the elementary form, and moreover, it is repeating 2 times, so we're going to balance it at the last. Okay. You understood? Understood?
Yes, sir.
Now talking about this one, okay. Now this is O2, this is CO2, this is water. Okay. Now we have to multiply this one by.
2.
Why should I multiply? No, this is carbon, and carbon and hydrogen you can balance because this is one time repeating. You can balance either any one of them. So which would you like to balance? Either carbon or hydrogen? It's your choice. You can balance the carbon, you can balance the hydrogen. So how many carbon atoms are there in CO2? How many carbon atoms are there in CO2? Yes, Ajwat?
1.
1.
1. Okay, so you have to multiply here by 2. So that will
Yes,
become
sir.
equals. How many hydrogen atoms are there? 6.
2.
6.
And here is 2.
6.
So by what
3.
number should you multiply?
3.
3.
Now, how many total number of oxygen atoms are there?
4.
4.
5.
5.
4 and
5.
3,
Okay.
7. Okay, but here is 2. So you don't have any number that you can multiply 2 to get 7 because there is only oxygen atoms. So by what number should 2 be multiplied to get 7? This is the important point. By what number should you multiply this to get 7?
3.5.
3.5 is actually 7 by 2. Okay.
Okay.
So this is right, 7 by 2, you cut it, you will get 7. So you have to multiply this whole as a 7 with 7. And then you have to multiply this whole by 2 because this is 2 in the denominator. So you will get 2C2H6 plus 7O2 will gives you 4 CO2 because this 2 and multiply with 2, you'll get CO4CO2 and this multiply with 3, you'll get 6H2O. Okay? Got it?
Okay, sir. Sure.
Yes, sir.
Everyone understood in the class?
Yes, sir.
Okay. Now this you have written the formula that you have we will provide you the in the class, you will be given the valency chart of that one. Okay, but there is some problem that the student need to face, and that is whenever you are writing that, if we talk that this react with air, yeah, burn in air. So burn in air means that it is reacting with oxygen, reacting with oxygen. Okay, for example, coal burn in air, hydrogen burn in air. So means hydrogen is reacting with oxygen to give water. Okay, got it? Got it?
Yes, sir.
And moreover, whenever we are talking about oxygen gas, so it does not means O, it means O2. Chlorine gas or chlorine gas, if it is written as chlorine, so it means O2, Cl2. Okay, this hydrogen when react with chlorine, it gives you, so hydrogen, if it is simple written hydrogen, then it is H2, not H. Okay, the metals generally are written as single element, like Na, like calcium, like magnesium. Okay, that they are written as single elements. But the elements that are important at hydrogen, calcium, chlorine, oxygen, okay, fluorine, that is F2, okay, bromine, that is Br2. Okay, so you need to write the names of these ones because these are very important. Okay, and that is ethanoic acid. This when react with ethanoic acid, that is the formula for ethanoic acid is CH3COH. So you can, this is a common name, ethanoic acid, or okay, or we also call it acetic acid. Acetic acid, CH3COH. Okay, next one is sulfuric acid. What's the formula for sulfuric acid? Formula for sulfuric acid, H2SO4, nitric acid, that is HNO3. Hydrochloric acid, that is HCl.
HCl.
So this is important, that generally been asked when you need to write the equations. Okay, so you don't know the formula of sulfuric acid because sulfuric acid, there's no sulfuric valency with iron. Okay, sulfuric acid. So how will you write? Sulfuric acid is actually hydrogen sulfate. So you can write a formula if it is being given to you to write the hydrogen sulfate. You can write it with the help of valency chart. But you can't write the formula for sulfuric acid because there is no such compound is written in the chart. So you have to write it from externally. Okay, so let me help you for the question that will be given to you in the homework. Okay, for example, let's take this one. Okay, for example, it is being written that nitrogen gas treated with hydrogen gas. So what does it means? Nitrogen gas means N2.
Nitrogen plus hydrogen.
Yes, but you cannot write INH, N or H. Nitrogen means N2. Hydrogen means H2. To gives ammonia. So you don't know the formula of ammonia, then how will you be able to write? So you need to write the balanced chemical equation for this. Okay. Got it?
Yes, sir.
Yes,
So
sir.
will you be able to balance this one? A.
Yes, sir.
Sodium hydroxide treated with acetic acid. So how do you know the formula of acetic acid? If there is no acetic acid formula, so I have written here that the formula for acetic acid is CH3COH. Got it?
Yes,
Got
sir.
it? And this is nitrogen gas. If I'm writing nitrogen gas is written as N2. Okay, but they are the two non-metals that are written as alone. Okay, let me help you here also. That for example, if it is written sulfur, this react with sulfur. So sulfur is written as S. Carbon is written as C. These are the two non-metals that are written single. Okay, other than this, we are right in like we have oxygen is a non-metal, that is O2, Br2, F2, N2, H2, I2. Okay, so we all of them will generally write them in the molecular form. And the metals are written alone. Like we have zinc react with calcium, zinc react with hydrochloric acid. So we will write zinc only alone. Sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead. So these are all written in the single form. Copper. So if you copper react with some like silver nitrate, AgNO3. So this is copper will be written like this. Not we don't write it C2. Okay, like we write in the non-metal. Got it? Got it?
Yes, sir.
So this is was written that sodium hydroxide react with acetic acid. The formula for sodium hydroxide is NaOH. Sodium valency is 1 and hydroxide is also 1. So that's what gives you NaOH. When react with CH3COOH, this is acetic acid. It will gives you CH3COONA. Plus you have to memorize this name that when this CH3 acid dissociate, like we have HCl. HCl when dissociated, it gives you H positive and Cl minus ion. When H2SO4 dissociated, it gives you it will gives you H positive, 2H positive ion and SO4 minus 2 ion. But when CH3COH dissociated, it will gives you CH3COO minus and H positive ion. So this is minus, and here this minus is reacted with this positively charged Na. So if you don't get this one, so let it be. We'll discuss this one later. Plus water. Okay. So this is sodium acetate. This is an important reaction. Please note it down. NaOH when react with sodium CH3COH, it will give you CH3CONA plus water, and it is balanced. And this is sodium acetate. Done? Noted?
Yes,
Yes,
sir.
sir.
Now this one ethanol. The formula for ethanol is, note down the formula of ethanol also. This is C2H5OH. Ethanol. The formula for ethanol is C2H5OH. Okay, this is going to study in the carbon compound, so don't write the equation. This is not in this syllabus, and this is also not in the syllabus, right? Means this is in our syllabus, but we'll learn this one in the carbon compound chapter. Okay,
Okay, sir.
and similarly, chlorine gas passed to potassium iodide to give potassium chloride and solid iodine. And ethanol burn in air. So this C magnesium burn in atmospheric gases. So these three can be in your this three can be asked. Okay, like we have magnesium ribbon burn in atmosphere of nitrogen gas. So atmosphere of nitrogen gas is N2. Okay, got it?
Yes,
Yes,
So
sir.
sir.
this is magnesium burn in atmosphere. So don't write Mg2 because it is metal. and nitrogen gas should be written as N2. Now the formula for magnesium is, magnesium valency is 2 and that of nitrogen is 3. You multiply this two, you will get Mg3N2. Ethanol burn in air to form carbon dioxide. So ethanol is C2H5OH. Burn in air means oxygen to give carbon dioxide and water. You can balance this one at home. Okay, so note the equations and then you can leave. Okay, that's all for today. Are you having any doubt, dear students, in this class?
No, sir.
Is there any topic? Is there any topic that you didn't understand? We will give you the valency chart and some equations, word equation to write them in the formula, and some unbalanced equation, a skeleton equation that will be written in their molecular formula, but you need to balance them. Okay, so this is the homework will be given to you.
Okay, sir.